Good evening, all. Welcome to interview preparation session. Let's start with the first question. Explain about epoch, batch, and iteration in neural network. What's an epoch? I will be giving you 1 more minute to respond in the chat window. Okay. Epoch. And epoch is nothing but whenever in a neural network, if we have a data set, if a data set moves complete data set moves forward inside the neural network and come back in the neural network, the flow of data inside the neural network completely once, it is known as epoch. When the data is flowing once throughout the network, then it is called as one epoch. You can have n number of epochs based on the okay. Sorry for the disturbance. Okay, next batch. What is a batch? Batch means if you have a neural network, in neural network, we can't have in neural network. See, if we have an input layer and this is an hidden layer and an output layer. Okay, I will explain first what is an epoch. Here, epoch means when we have a data set, something like we have a data set of approximately 1,000. If you think it, we have a 1,000 data set. Once whole 1,000 data set moving forward and coming backward, then it is called as one epoch. We can have a number of epochs based on the hyperparameter. It is one of an hyperparameter tuning. So number of epochs we will be deciding. Next is what is a batch. Batch means, see, if you have an 1,000 images, consider you have 1,000 images. If you are passing through an network, then once if you pass 1,000 images at a time, then the complexity of the model increases and the complexity of doing this one increases. So what we will do means, here we will just split this 1,000 data sets into, consider we are sending at a time, we are sending 50. What we will do, we will send 50 at once, and once we will send 50, and once when it flows back, then whatever the error loss are calculated, and next 50 are will be sent. This in the whole data set is split into batches. This is called as batch. This is known as batch. What is iteration? So if you consider, if you consider here, we have an 1,000 data set, and and in that we are sending 50 at a time. So what is the iterations means, number of iterations means, here 50 1,000 divided by 50, what we will get, then we will get 20. This is number of iterations. This is the number of iterations what it goes. Am I clear? Shall I go to next question? Okay, next question. What is an activation function and why do we use them? I will be giving you 2 minutes for responding. Yeah. Softmax, Relu, these all are activation functions. Yeah. So what is an activation function and why we should use them? Yeah, Ipsita, those are activation functions. Okay. Activation functions are used. These are the functions decides whether the neuron, whatever the neuron, should be activated and not by calculate by how we will do means we will be activating not by calculating the weighted sum, and even by adding the bias. What we will do means we will be having, if we have an activation function, we will be taking all the weights into input data whatever we are giving plus bias that will be fed to the activation function. We will be getting output. Why we are using activation function? We are using activation function in order to introduce non-linearity to the output of a neuron. This is why we are using activation function. Okay. Okay. What is a perceptron? Yeah, Shalini, you are correct. Yeah, perceptron is used in multi-layer perceptron. What is perceptron? Okay, a perceptron is an algorithm which is used for supervised learning. Means supervised learning, which we know the output. Whichever the y is there, we will be already knowing, and this is used for binary classification. Perceptron means single. Means a single neuron. It is a single neuron. A perceptron is a single layer neural network. What it contains? It contains an input layer and an output input layer, and weights will be there, and bias, one bias will be there. Okay, here in this image we don't see bias. Here one bias also will be there. Bias will be there, and that summation will be given to feed it to an activation function. Will be fed to an activation function. This is what an perceptron is. What are the types of what are the different types of perceptrons? Okay, I will be giving the solution. Um, Types of perceptrons is single layer perceptron. Whatever, if we have a single perceptron, then it is called a single layer perceptron. If we have many perceptrons, many, then we can call it as a multi-layer perceptron. Where we use single layer perceptron? Single layer perceptrons are used for the we can use for learning linearly separable patterns, which are linear. Means whichever the patterns which we have linearly, those for those kind of problems we can use single layer perceptron. If we have something non-linearity, then we will be going for multi-layer perceptron. In multi-layer perceptron, what will be there means it is nothing but it can also be known as feed-forward neural network. Here, what happens in single layer perceptron, you will be having one layer, but here we will be having two or more layers, means two or more hidden layers, so that it will be having high processing power, so that it can handle non-linearity problems also. Okay. Next question. What do you mean by cost function in neural network? Yeah, it's you are correct, somewhat correct. You are correct. Yeah. Uh, what what the cost function in neural network means? Cost function is nothing but which is used to for explain for knowing how well our model is performing. Means how well the model is performing means it is nothing but we are finding out actual means training data, for training data and expected output, how well they are assigned, means how good our model is performing for input data, and for whatever we are expecting for the training sample, whatever the given training sample and whatever the expected output we are getting, how good they are matching. This is what the cost function gives us. How where means cost function depends on weights and the bias. Here, weights and bias, it depends, but every time we are while training the neural network, weights and biases are altered, means updated, so that the cost function will be reduced. Okay, let's go to the next question. What is backpropagation? Okay, backpropagation. Backpropagation algorithm is used to train multi-layer perceptron. See, here if you think this is an input, if you have something like this input, and you have an hidden layer. you have an hidden layer like this, and you have an output layer. So these are connected. All these are imagine that like this. All this network is connected. Here, backpropagation algorithm, what we will do, this is multi-layer perceptron. Now you know what's a multi-layer perceptron. Here, if this is a multi-layer perceptron, what the backpropagation does means, it will be the propagating the error information. Whatever the error means, whatever it is predicted and whatever the actual is, if we subtract these two, we will be getting an error. This error information will be flowing from one end to another end. Means this will be flowing from back to front. During this flow, what we will be having derivatives means del by dou. This will be updating. This we will be finding weights. Weights will be updating over here. Weights where W is equal to new weight. New weight is equal to W volt minus learning rate into del by dou. Here in the back propagation, this what happens. If, like this, the weights will be updated. Means the updation for the weights will be given. This allows that this affects the computation of the gradients. Gradients or derivatives. This is what the gradient or derivatives. These derivatives will be efficiently updated. Means we will be derivatives we will be getting. This is what the back propagation means. The flow, it will be from back to front, but the values assigning will be from forward to backward. What do you mean by gradient descent? I will be giving you 2 more minutes to respond. Okay. Uh, gradient descent. Gradient descent is nothing. It is an optimization algorithm. What the optimization means? In order to we do optimization so that we have to minimize. Here it will minimize the cost function. Whatever we are talked earlier about the cost function, we need to minimize. How we are minimizing? We are minimizing by using gradient descent, which is an optimization algorithm, so that it minimizes the error. What is the main objective? The main objective of the gradient descent is, in order to reach here, it has to reach global minima or local minima. Usually local minima, but here main objective is to reach any of them, one local minima or global minima function based on the convergence, convexity. Here, if you see, if I plot here, see, consider this. See, if this is the one, here this is the gradient. If you this is you are at this point. If you are at this point, what is the line we had drawn tangent to that point for that curve, that is called as gradient. This we call it as a gradient. Initially weight, this point is the weight initial weight. So what we have to do, what the gradient descent optimization do means, it starts in the every iteration, it starts moving down. The weight will be start moving down, and it has to reach a certain point such a way that it has to reach a local point, local minima or global minima. Here, if you see it, this is a picture. This is an uh, uh, local minima or a global minima. Both it can be, because we have only one minima point, so it is both. We can consider any one of it. This is what the gradient descent is. What are the different types of gradient descent? Yeah, Ipsita, you had already given solution for this question. Okay. The different types of gradient descents are: one is stochastic gradient descent, another one is mini batch gradient descent, another one is batch gradient descent. Then what is stochastic gradient descent? The stochastic gradient descent is, in this what we do, input hidden layer and an output layer. If you have input hidden layer and output layer, whatever the data sets, if you have some data sets, data of 1,000 inputs, if you have 1,000 inputs, if you are sending one input at a time, one input at a time, and you are flowing one input at a time, and it flowing, then it is called a stochastic gradient descent. Then what is a mini batch gradient descent? Mini batch gradient descent is nothing but, in this one, what we will do, a batch size means, we will be giving some batch means, uh, if you have think you have 1,000, right? You have made into a batch of 50 data sets of 50 at the one batch. This is one batch, making a batch. And if you are sending 50 data sets at one epoch, then it is called as mini batch. We are splitting the dataset, whole dataset, into small batches. Then what is batch gradient descent? Batch gradient descent is nothing but, if you are sending whole dataset at a time. At a time you are sending whole thing, and you are doing you are training the neural network, then it is called as batch gradient descent. Here you will be sending one at a time. Here you will be sending a mini batch, a batch of small batches. Inside the whole data will be splitting into small batches, and you will be sending. Here batch gradient, you will be sending whole data. Okay, let me go to the next question. Explain the effect of learning rate on neural network. How learning rate affects the neural network? I will be giving you 1 more minute for responding in chat window. How learning rate affects training of the neural network. Okay. Yeah, you can still you have time to respond in chat window. Here, see, learning rate. Learning rate is an hyperparameter which can be tuned for an model so that based on the uh, learning rate, this is one of the hyperparameter tuning element. See, if we have what happens if we have high means a learning rate value will be somewhat from 0 to 1. If you see, if you have a learning rate which is low, if you consider if you have a learning rate low, what happens here? Weight initialization, whatever the weight initialization is there, right? The weights w is equal to w new is equal to w world minus learning rate. Learning rate into whatever the derivative of error with respect to weight, cost function or whatever we can say with respect to weight, we will be calculating and weight updation will be there. Here what happens when the this learning rate is too small, when it is too small, your weight updation will be slow. It takes so many steps. See, it moves from there to here, then it moves from here to here. Next point, from next here to here, then hit from here to here, from here to here. It takes so many steps to reach the minimum point. If you consider learning rate is more, if you consider if it is having it, learning rate is high, then what happens means the loss function due loss function this is value is high, right? So what happens? Weight updations will be more. Weight updation will be more. So what happens? It leads to jumping from, instead of, see here, it should reduce here. If the weight updation is too much high, then what happens? It starts moving somewhere here. Then whenever next updation, it may move here. Means it won't be going towards the normal if the learning rate is too much high. This is what the problem if it is learning rate is too high, and when if it is too less, it takes too much of time to converge. So if we have an optimal learning rate, then what happens here? Flows will be for initially the bigger steps will be there, then the step size will be reduced so that it reaches the normal very easily. This is how the learning rate affects the neural training the neural network. Next question: what are hyperparameter tuners for learning neural network? We had seen one that is learning rate. Other hyperparameters for neural network. I will be giving you 1 more minute to respond in chat window. Okay. Uh, Sorry, Sita. Uh, Not that. Okay. Hyperparameter tuners for neural network are number of hidden neurons, or you can call it as hidden units. Whatever we will be having input layers and output layers. In the middle, we will be having hidden layers, right? In hidden layers, even the number of hidden neurons, whatever present, this these neurons plays an important role based on the number of neurons. This is also one of the hyperparameter tuning. And learning rate, we studied just now about the learning rate and number of epochs. Yesterday I told, if we have see, if we are doing one epoch, if we are done one epoch, if we are trained for one epoch, then your model will be underfitting. Means it has not learned everything, right? Then when you keep on increasing the epochs, it starts moving towards the best fit model, means good fit model. Then even after the model is fit, even if your epochs are too high, then what happens? It leads to overfitting. So here even the epoch is also an hyperparameter tuning. Then we have activation functions. Based on the type of the problem, we have to use the activation functions. We have so many activation functions like ReLU, leaky ReLU, sigmoidal, tan hyperbolic. We have so many things. These are the activation functions. They're based on the problem output required. We will be selecting the activation function, and this is also one of the hyperparameter. Then optimizers are used to these are used to minimize what we are minimizing. We are minimizing the cost function. To minimize our cost function, we are using optimizers. We have studied about optimizers now, just now, gradient descent, in that we have different one. These are the optimizers. Best, which is the best optimizer we feel we should use that one. These are all the hyperparameters for the neural network. We will be moving to the next question. What is vanishing gradient problem? I will be giving you one more minute. Okay. What is vanishing gradient problem means? See, when we have a neural network, if the neural network is small, no issues. When we have a huge neural network, this is an input layer. You consider this as an input layer, and we have hidden layers. In the hidden layers, when we have too many layers, one layer, two layer, something like three layer, four layer, five layers, six layers. We have so many hidden layers. Okay, and we have an output. Here is the output. Okay, this is an output, this is an input, and we have so many layers. So what happens when upgradation we have to do, right? When weight upgradation, you consider here we have one more neuron, here we have one more neuron. What happens, this here weight up when weight upgradation, here also it needs weight upgradation, right? Here weight will be given to the input. Here also, if you have a neuron, here also weight upgradation should happen. Here here once the actual and predicted loss will be predicted, here when the weight upgradation is going on, for if you consider this one, then it will be, you consider this as a 1, this as a 2, this as a 3. Dou L by, if you, this will be dou W3 into dou W3 by dou W2. Sorry, dou W3, here it is 3, it is dou W2. Next, into dou W2 by dou W1. This is what? This is dou L by dou W1. You know chain rule, right? Like that, this is how that flows. If you think, when you have used an activation function, something like, for example, you had used ReLU. You consider you had used a ReLU activation function. Whatever the output you are getting and the derivative, whatever you are getting, it will be even, sometimes it will, ReLU is from 0 to 1. You are getting a derivatives which are close to 0. Means something you are getting 0.01, 0.1. Okay, let it be 0.1. See, here also somewhat 0.01. Here also 0.01, which are close to 0. Means you think the points which are close to 0. When these products are done, you will be getting point something like 0.0, 0.0000001. Right? What happens? Your weight upgradation here, if you are waiting weight upgradation, you are thinking just for 3 steps. 3 steps weight upgradation. New weight is equal to old weight minus eta. Eta into whatever you are giving this dou L by dou W, dou W1. Means if you are consider dou W1, this is the weight of dou W1. If you consider this, see whatever this one you are getting, it is tending towards the 0. When what this happens, when this is subtracted with the old weight, there will be no change. See, this is leading to no change in the initial value. So means in the initial neural network, only the weight upgradation will be taking place at the final network, and no weight updation will be at the neurons which are present at the front stage. So this problem is called as, it is tending to 0. This kind of problem is called as vanishing gradient problem. Okay. Am I clear? I will be going to the next question. What is exploding gradient problem? I will be giving 1 more minute for you to respond, guys. Okay. uh Exploding gradient, I will use old image here itself. See, if you are getting something values like close to zero, if your values are getting close to zero, what it is happening, it is tending towards the zero. Instead of you think somewhat whatever the value here, it is something like this, right? Linear. Whatever the higher values, you are getting something value which is higher. Means you think you are getting somewhat like 20. You think like 20. Okay, let's take not 23 only. Let's take 3. Something like 3, 4, something we are getting here. What happens if we are producting this 4 into 3, some value 12. 12 into 3, 36. If we product, if we are taking just a small numbers, if we are getting a huge number, then what happens? The values will be raised very high. This kind of problem, this value will be increasing too much, so that this kind of problem is called as exploding gradient problem. See, while back propagation, in back propagation, whatever it is happening, network in n hidden layers, n derivatives, whatever the derivatives I told, right? Dou L by dou, those derivatives are multiplied together. These are multiplied together. If the derivatives are, oh sorry, if the derivatives are not small here, so it is a vanishing gradient one. If the derivatives are large, whatever the you are getting is large, then that leads to, this leads to exploding gradient problem. Okay, this leads to exploding gradient problem. Okay, what do you mean by optimizers? I will be giving you 1 more minute for you to respond in chat window, guys. Yeah, okay, let's go to the solution. What are optimizers? Optimizer is not, they are the algorithms. They are algorithms or the methods that are used, for used to change the attributes. What are the attributes? Attributes in the neural network. What are the attributes? Means attributes are nothing but weights and the learning rate. Why we are changing the attributes? We are changing the attribute to reduce the cost function. That is loss. To reduce the loss. Optimizers optimizers are used Optimizers are used to solve optimization problems. Means like minimizing the function. This is what the optimizers are. We have so many number of optimizers. We have seen optimizers earlier even also, like we had stochastic gradient descent, stochastic gradient descent, and even what we had seen, we have optimization functions like gradient descent. Okay, another one stochastic gradient descent, and we have mini batch stochastic gradient descent, and we have SGD, stochastic gradient descent with momentum. We have this one more optimizer, and we have nag nag energy. This is also one more optimizer, which is called as Nestro accelerated gradient, and we have ADA grade. ADA means which is nothing but adaptive gradient, ADA delta, and we have one more RMS probe. We have so many optimizers, guys, based on requirement, and this is also an hyperparameter tuner. So based on our requirement, we will be selecting any one of the optimizer and using for the neural network. Next question. What do you mean by CNN, convolution neural network? Okay. CNN. A convolution neural network is a neural network that is used to enable machine to visualize the things. This is a type of neural network which enables the machine to visualize the things. See, convolution neural network is one which is used to visualize the things. The mainly where we are using CNN. CNN is used for the problems or problem cases like image classification. We have to classify the image whether it is a dog or cat or horse or something like that. We want to classify the image. For that one we are using image classification, and for image recognition, to identify the image, who the person is, something like that, we are using this one, image recognition. Even for the object detections and recognition of the face, if you want to recognize who the person is, for that kind of problems we will be using CNN. Okay. Okay, I will see here. If you can see here, this is an CNN neural network. Here, this is called as a CNN neural network. Here, whatever you are giving an image. The input is an image. Here, this image will be identifying whether it is a bird or whether the image is an of a dog or a cat, or you had sent an image of sunset, means the image of sunset. Like that, it will identify what the image is, and it will be classified, and they will be giving the probability of what the image is. Means probability value will be giving, based on that it will be predicted. Here in this one, we will be having convolution layers, and then we will be having a dense layer, and we will be having an output layer. Okay, we will be moving to the next question. What is padding in CNN? Okay. Uh, padding is nothing but, if you consider you have an image. Uh, you have an image. This is what the image you have. Uh, Before you are doing padding means you are adding extra, means you are adding extra pixels around the image whatever you are having. Around the your image whatever you are having, you are adding the pixels. These are pixel values, these are whatever which are present inside this one, these are pixel values. Here you are adding the pixels, you are adding these pixels around the image, in order to be, when we will be adding while being processing in CNN. Here, this is called as zero padding. Means the values, whatever the values we are added around this, these are zeros, right? This is called as zero padding. We will be adding two layers, two padding. Here, this is called as padding. You neglect these things. This is not required here. We will be talking about this later. This is what the padding is. Next question. What what is the term? Same padding. Okay, same padding means same padding. Same padding in CNN means. Okay. Uh, I'm going to this one. What is same padding? Same padding means here, whatever you are doing the padding here, right? Even after padding, means when you apply the filter, okay, uh, we are padding here. What we will be having? We will be adding the padding element all around the output matrix. After this padding, when we get the dimension of the input matrix, whatever the input matrix is same as that of convolution matrix. Here means what after the convolution, whatever the convolution happens, the size of this one means here what is the size of the image you are giving? 1, 2, 3, 4, 5. 5 cross 5. You are giving the image size of 5 cross 5. And after applying the convolution, if you after the applying convolution with the filter size of 3 cross 3, you are getting this, you are getting the output image which is having a size of 5 cross 5. 1, 2, 3, 4, 5, 5 into 5, 5 cross 5. See, if same padding is nothing but the input image, whatever the input image is, when it is padded in such a way that the filter, when we apply the filter, the output image size will be equal to the input image size. Then it is called as same padding. If you had not done the padding, you have a 5 cross 5. If you had not done the padding, and you are applying a filter on it, then you will be getting an output 3 cross 3. If you had applied an filter size of 3 cross 3, it has a formula like padding size means n minus the number of filter size divided by stripes. That formula, based on that formula, you will getting the output size of the image. This is what the term same padding means in CNN. Okay. Am I clear, guys? Okay. Thank you for attending the interview preparation session. Um, I will be ending this session now. Thank you all. Thank you, Shalini.